All right, so in this video, we are going to talk about how we can use square and cube roots to solve problems involving geometry. So we've got some Pythagorean theorem problems and some volume problems that we're going to work on. I do have my Desmos scientific calculator pulled up to the side just to help me with my calculations. All right, so remember back to when we did Pythagorean theorem. It had to do with right triangles, and it told us that a squared plus b squared was equal to c squared. Now, a, you probably remember, was the side length that represented one of the legs of the right triangle, so one of the sides that makes up the right angle. Same with b. B was the other leg, or the other side that made up the right angle. So when we're given 9 and we're given 4, we want to plug those values in for a and b. What we don't know in this diagram is the hypotenuse, the longest side of the triangle, which is the value c in Pythagorean theorem. So that's what we'll be solving for. So let's go ahead and take and plug in 4 for a, so 4 squared, 9 for b, 9 squared, and let's see what that gives us for c squared, which is what we're trying to find. So 4 squared, 4 times 4 is 16, 9 squared, 9 times 9 is 81, that is equal to c squared. And so if we add those up, we get 97 equals c squared, but that's not this missing side. We still have to take the square root of both sides to see what c is. I'm sure it's going to be close to 10, since the square root of 97 is pretty close to the square root of 100. But I'm going to click this square root symbol here and type in 97. And I'm going to round to the nearest hundredth. So the missing side is about 9.85, which is good because C should always be the longest side in the triangle, which it is. So in this next example, the side that we don't know is A. So we don't know one of the legs of the right triangle, so we're going to be finding A. We do know B, we know the other leg of the triangle is 6, and we know C, which is the hypotenuse, the longest side of the triangle, is 12. So we're going to leave, since we don't know it, we're going to leave A squared. We're going to plug in 6 for B, and we know that's equal to c squared, and in this case, c is 12. So a squared plus 6 squared is 36, 12 squared is 144. So I need to solve for a. So first, I need to subtract 36 from both sides, and this is why it's handy to have your calculator pulled up. 144 minus 36 is 108. So a squared is equal to 108, but that's not the missing side. I still have to take the square root. And so the square root of 108 is going to be a little bit bigger than 10. If we round to the nearest hundredth, 10.39. So that is the missing side of this triangle, which is not bigger than 12, so that's a good thing, because 12 needs to be the longest side of that triangle. All right, so in this next problem, we are given a cylinder and we're asked to find the radius. The radius is what we don't know. We do know that the volume is 565.2, so that's going to get plugged in for V. We know that the height of the cylinder is 5, and as we did back at the earlier in the year, for pi, we're going to use 3.14. So we're going to plug all those values in, and then we're going to solve for r. So we get 565.2 is equal to 3.14 for pi. And then r squared is what we don't know, so we're going to leave that in there. and then we're going to plug in 5. So on the right-hand side, this is all being multiplied together, all of these terms. So we're going to figure out what is 3.14 times 5. Let's multiply those together. So 3.14 times 5 is 15.7. So 15.7 is the coefficient of r squared, is multiplying r squared. So to get r squared by itself, I need to get rid of the coefficient of 15.7 by dividing by both sides by 15.7. So 565.2 divided by 15.7 gives me 36. So 36 is equal to r squared, and since r is being squared, I have to take the square root of both sides, and I know the square root of 36 is 6, so the radius of my cylinder is 6 inches. We're also going to have to solve some problems with spheres. So here we know the volume is 7,234.56, so that's going to get plugged in for V. And then the only other variable or unknown in this problem is r. So we're still going to use 3.14 as our value for pi. And so let's see what we get when we plug those values in. So 7,234.56 is equal to 4/3 times the value of pi we're using is 3.14 times the radius cubed for a sphere. So again, we're going to multiply the numbers that are next to the r together. So 4/3 times 3.14, we'll round to the nearest hundredth, is 4.19. So we get 7,234.56 is equal to 4.19 times the radius cubed. So again, that's the coefficient of r. So we're going to divide both sides by 4.19. And let's see what that gives us. So 7,234.56 divided by 4.19. If we round to the nearest hundredth, is 1,726.63. That's not our radius. R is being cubed, so the opposite of cubing something is taking the cube root. So let's take the cube root of both sides. And so to take the cube root on Desmos, we're going to click this button, and we're going to type in that it's a cube root, and then we'll type in the actual number. And so if I round this is pretty close to 12. It rounds up to 12. So my radius here is 12 centimeters.